Hello everyone, welcome to switispeaks official YouTube channel. My name is Sweety Pinjani. This is UVM Advanced series, which is a continuation of UVM Basic series. In the previous lecture, we saw in order scoreboard, wherein the output of the scoreboard is in order of the output which comes from the driven stimulus. Today we will see the out of order scoreboard. Let's get started. What do I mean by out of order scoreboard? The name out of order suggests that the output order of your scoreboard output is the expected output. The order of this output is different from the output which comes from the driven stimulus. Output which comes from the driven stimulus is the actual output, which means in out of order scoreboard, your expected output order is different from your actual output order. The expected output is calculated by reference module. The reference model calculates this expected output based on your input stimuli. And the actual output which comes from the DUT, actual output comes from the DUT, it can be in any order. Now, since the actual output can be in any order, the expected output which is calculated from the reference model, it's not sure that it will be in same order compared to your actual output. In such case, your reference model has to store the transaction, this expected output, until it receives the corresponding actual output. Because until you get both expected and actual output, you can't compare them. In order to store these transactions, your reference model uses associative arrays. Why do we use associative arrays? Associative arrays have indexed, and you can identify the transaction order based on the index. And based on the index, you can compare your actual and expected output. So in associative array, based on your index value, the transactions are stored in expected and actual associative arrays. And then you will match the index to compare this expected and actual outputs. Entries from this associative arrays will be deleted when the comparison is done. Let's understand this with the help of diagram. You have the reference model. To reference model, you need to give some input. This input will come from your input FIFO, which will have the input transactions. These input transactions you will give to the reference model, which will have the logic to calculate your expected output. And the output of your reference model will be your expected output or the expected transaction. And then from the design, you will get the output, actual output, which you are storing in the output FIFO. Now remember, this is out of order. It means it's not necessary that your expected output and this actual output is in order. It can be out of order. How will we identify? With the help of index. Here you can see it is out of order. First I got index 15, then I got index 7, then I got index 2, then I got index 10. With the help of index, I'll identify it. This is the out of order scoreboard. Let's understand out of scoreboard code. We will understand each and every line. Pay attention. The first step is you need to create a scoreboard class by extending from UVM scoreboard. Here you can see I have created a scoreboard class Sweety out of order scoreboard, which extends UVM scoreboard. Then you need to register this class with factory. Since scoreboard is a component, I will use UVM component utils, and this is the name of my scoreboard class. Then I need to create the analysis exports, TLM analysis FIFOs, associative arrays, and index queues. These are the analysis exports which are parameterized by the transaction class. The transaction class which I am using is Sweetie transaction. I need two analysis exports. One is for input and one is for output. Similarly, I need two TLM analysis FIFOs. Again, these are parameterized by Sweetie transaction. One is for input and one is for output. Then I need the associative arrays. Why am I using associative arrays? Because this is out of order scoreboard. There is no guarantee that your expected and actual output will be in order. That's why I need to store these transactions with the help of index. Associative array has an index, and I will identify these transactions with the help of index, and I will compare the expected and actual outputs with the same index so that I compare the correct transactions. That's why I'm using an associative array. And another advantage of associative array is when you don't know how many number of transactions are there, you can use associative arrays. That's why we are using associative arrays. Again, we are using two associative arrays. One is for expected output and one is for actual output. Now I also need to save the indexes. To save the indexes, I am using the queues of the type int because the index is of type int. I have expected output queue and I have actual output queue. Then I need to implement the method new. Here, new will have two arguments because scoreboard is a component. First argument is name, which is name of your scoreboard, Sweetie out of order scoreboard, and second is the parent. And then you will call super.new, and there you will pass two arguments, name and parent. Then you have the build phase. In build phase, you will create instances of export and FIFO. Here you have two FIFOs, one is for input and one is for output. Similarly, you have two exports, one is for input and one is for output. Using the new method, you are creating the instances. Then in the connect phase, you need to connect these exports to the respective FIFOs. The input export is connected to the analysis export of the input FIFO, and the output export is connected to the analysis export of the output FIFO. Next, we need to implement the run phase. For run phase, we will need the transactions. There will be input transaction and there will be output transaction. Both are of type Sweetie transaction. Then I have a forever loop and I have fork join. Because fork join, what it will do, it will execute this begin and in parallel. This begin and whatever is inside this begin and whatever is inside this begin and, both this begin will start executing in parallel, but each line within this will start executing in sequence. Like inside this begin and, first this line will execute, then this line, then inside this begin and, first this line, first then this line, then this line. This is the requirement. I had covered fork join in detail. If you see, there is System Verilog Essential series where we had covered this fork join in detail. If you want, you can go through that. So here what I am going to do, I am getting the input transaction from the FIFO. I have the process data method inside my reference model. In that, I am passing this input transaction. Then I am getting the actual transaction from the output FIFO. Here, if you can see, output FIFO.get, and then I am getting the transaction. Now, remember, this is out of order scoreboard, which means the transaction may not be in order. Whatever transactions you are getting from DUT may not be in order. For that, what we have to do, we have to use associative arrays to store your transactions, and there we will store the transactions with the help of ID. So here you can see whatever transaction I got, this I am storing in the actual output array, because this is output FIFO, which means output of the design, which is actual output. I am storing this transaction in the output array with the help of ID. whatever id is there, in that particular index only I will store. For example, it is 15 transactions, so I will store in the index 15. And then I am also storing the index whatever I got in the actual output queue. And once this is done, once you are saving the transaction inside your output arrays, you will compare the data. Call this method to compare the data. We are going to see what this method is. We have this method upcoming. For now, just remember that we will call this compare data method in the run phase. Now, since these are out of order transactions, we also need to make sure that all the transactions are compared. So we have a check phase. In this, what we are going to do, there is super.check phase which we are going to call, and we are checking if the expected queue is empty or not. And we are also checking if the actual queue is empty or not. Then next, we have the process data. In process data, what we have to do, we have to calculate the expected output. This will have the expected output transaction, which we have to calculate. And here what you are going to do, you will have the logic to calculate your expected output depending on the input stimulus. And then this expected output you need to store inside the expected output array with the help of id. Whatever expected output you are calculating depending on the input, whatever is the index of input, that particular index will go to your expected outputs. For example, you are calculating the expected output for index 15, so the expected output array also, it should be stored in index number 15. So you are taking this index from your input sweetie transaction, which is your input to the process data, and then you will store whatever the expected output you calculated in this expected output array with the corresponding index, and you will store the index in the expected output queue. Now we have the compare data method. In this, we need to compare the actual and expected output with the help of index. Because this is out of order, that's why matching the index is important. Here you have expected transaction and actual transaction. You will compare if the array size is greater than 0. If array size is 0, it means all the comparisons are already done. Now here what you will do, you will first see the index from the expected output. What output is calculated, you will check the index of that. The index was saved in expected output queue. So you are popping the first expected output and you are checking if the actual output is available for that particular expected output or not by using exist method. This methods we have seen in the associative arrays. There is a tutorial on associative arrays. There we have seen this method exist. So it checks whether this particular index exists in this particular associative array. If it exists, then we will assign this expected transaction to this. We will take this expected transaction and assign it to the expected sweetie transaction, and we will take the actual and assign it to actual sweetie transaction, and then we will compare these two. And if these two are compared, like the comparison passes, well and good. If it doesn't, then you will throw an error that that these actual and expected transactions are not matching. And if say the comparison passes, it means they are matching, then we will delete this. Expected output also you will delete, and the actual output also you will delete. Otherwise, if they are not matching, you will say the actual output is not found. It is still not there, then you will push the index back. Expected output, you will push it back because this comparison is still not done. Understand each line. It's very simple. Don't get confused. If you understand these two lines, you will understand what's going on. Compare data is one of the important things because the transactions are coming out of order. How we are comparing? With the help of index. When we are comparing, only when the expected output array q and the actual output array q size is greater than 0. If it is there, we will check if the actual output array exists for that particular index. If yes, then we will assign the respective values to this particular variables, which we have expected sweetie transaction and actual sweetie transaction, and we will compare. If the comparison fails, we will throw error, else we will delete the respective entries because the comparison has happened. If the actual output does not exist, then we will push back the index inside the expected output queue because this comparison is still not done. So once this actual output is available, we will compare it again. This is the out of order scoreboard. Now let's summarize it quickly. Out of order means the output is in different order from the driven stimulus. It is implemented using associative arrays. Steps to create out of order scoreboard. First, you need to create the scoreboard class by extending from UVM scoreboard. Then you will register it with factory. You will declare analysis export, TLM, analysis FIFO, associative arrays, and index queues for both inputs and outputs. Then you will implement the new method. In the build phase, you will create instances of export and FIFOs. You will implement the connect phase where you will connect the exports to the respective analysis FIFOs for both inputs and outputs. Then you will implement the run phase. You will check for the pending entries because it is out of order. You need to ensure that everything is compared. And then you will generate the expected output in the reference model. You will compare the expected and actual output. This is out of order scoreboard. I hope you understood. Please go through the code again, one line by line. Understand each line and try to code by yourself. I'll keep on coming with such videos. If you want to stay tuned, please subscribe to Sweetie Speaks official YouTube channel. Thank you.